Hi everybody, Gary Porter again. Now working on the light bulb in the water test, and this circuit will also be used with my propulsion system's three-level generator. But first things first, I want to try the lighting of the light bulb in the water and put my hand in there and see what happens. So maybe I live and maybe I die. We'll see. Anyway, this is what I've got. Right here in the front, there are on the black plastic, I've got some dowels inserted, a variety of distances apart. I've got some copper tubes here, a variety of sizes. The pair of long ones go in these dowels, and the spark gap is here. This is my original spark gap from the Don Smith circuitry. There's two neo magnets and then the spark gap itself, and I can change this around a little bit and maybe use different size screws. I've got a variac here, 12-volt battery, and you need to use a pure sine wave inverter to run the 9,000 volt transformer over here. And I've also thrown a cap in here for tuning, 60 cycle tuning between the variac and the high voltage neon transformer, which has no ground fault circuitry in it, so that runs, if there's a spark gap going involved, it would shut it down if it had the ground fault circuitry. And a little on-off switch, and this whole circuit should draw about the same as my original Don Smith stuff. These parts were used in the same thing, and that should draw about 3.5 or less amps from the battery. And we'll know more about that in a little while. These tubes go into the dowels, as I said, and I'm using these pipe clamps to attach the wires at different points along this surface to see what the light bulbs do. I got a variety of donut-shaped caps, some Russian ones, and I guess most of these are Russian, and a variety of sizes and voltages and microfarads or nanofarads or picofarads or whatever we're going to use here. And the deal is you got to go above 10k hertz on your oscillating frequency during the spark gap time, and that'll keep it safe. If you go below that, well, you're in for maybe a shocking experience. But anyway, anything over 10 kilohertz, Tesla said, will work good. And I've got to reread his researches and writings book. Discusses things he did around this copper tubing environment with the short circuit and not short circuited, with different positions and nodes he found, and I've got to study that some. And but when you think about it, what this actually is a Tesla single turn primary, and something like what he used in Wardenclyffe, and also what he used out in Colorado Springs, and also in New York before his lab burned down in 1895. So anyway, that's how close I am. I'm getting real close. I only got a few more wires and we can fire it up and try to light a light bulb underwater. Have a nice day.